Okay, so tonight, October 21st, 2025, if you step outside and look up, you are literally witnessing something incredibly rare.
It's pretty special.
We're not just talking about one bright comet, which would be cool enough. No, we're right in the thick of this unique cosmic alignment.
That's absolutely right. We've got two bright, long-period comets, Comet Lemmon and Comet SWAN.
Yeah.
And they're both making their closest pass by Earth, like right now, simultaneously.
And the timing is just, well, it's almost unbelievable. It elevates this whole thing from just interesting to something you really, really need to see.
It really does, because this dual approach, it lines up perfectly with two other amazing things happening tonight.
Exactly. First, the new moon. That means no moonlight washing things out. We get maximum darkness, perfect deep sky conditions.
The best possible backdrop.
And second, it's the peak of the Orionid meteor shower tonight, too.
Yeah. So you've got potential shooting stars, these two comets glowing, and zero moon interference. It's an observer's dream scenario.
It really is. So we've gathered all the sources, the orbital data, the finder charts, the latest reports, and our mission today is pretty clear.
Yep. We're going to dive deep into the technical side of these two icy visitors, but more importantly, we'll give you the practical guide how to actually find them tonight.
Okay, let's unpack this.
Let's do it.
Maybe start with the basics. These two comets, Lemmon and SWAN, they might look kind of similar up there, these fuzzy green blobs.
Right.
But they're actually fundamentally different, aren't they? Like almost opposites in their journeys.
Oh, completely. And that's what makes this so scientifically interesting. It's a fantastic chance for comparative study, seeing these two radically different paths through the solar system at the same time.
So tell us about Comet Lemmon first. C2025A6.
Okay, Lemmon. Discovered earlier this year, January 3rd actually. Found by the pros, the Mount Lemmon survey team in Arizona. And they spotted it when it was incredibly faint.
Really faint.
Like magnitude plus 21.5 faint. Just unbelievably dim back then. And the key thing about Lemmon now is that it's inbound. It's still racing towards the sun. It's perihelion, its closest point to the sun, is still coming up. That's on November 8th.
All right, so inbound Lemmon. Now contrast that with Comet SWAN, C2025R2.
Right. SWAN is the mirror image, journey-wise. It already had its close encounter with the sun. Perihelion was back on September 12th.
So it's heading out now.
Exactly. It's outbound, moving away from the sun, on its way out of the inner solar system.
The discovery stories are pretty different too, aren't they?
Totally different. Lemmon, as I said, professional survey, super faint detection. SWAN, though, that was a fantastic citizen science discovery.
Oh, yeah.
Yeah, it was spotted much later, just last month, September 11th or 12th. An amateur astronomer, Vladimir Bazugli, found it by looking through publicly available data from NASA's SOHO satellite.
Wait, SOHO? That name rings a bell. I feel like we hear about SOHO finding comets quite a bit.
You do, yeah. SOHO stands for the Solar and Heliospheric Observatory. Its main job is watching the sun.
Right.
But one of its instruments, called SWAN, which actually measures solar wind well, the data it collects often reveals comets that get close to the sun. And because the data is public...
anyone can look through it and potentially find one, like Bazugli did.
Exactly. A real triumph for citizen science.
Yeah.
So you have this contrast.
Yeah.
The big professional survey finding one, and an amateur analyzing public data finding the other. It's brilliant.
Okay, before we dive into where to look, let's talk about that color. You mentioned fuzzy green blobs. Why green? Why do they both have this like bright lime green look?
Good question. That green color is basically the comet's calling card. It tells you it's active.
Active.
Meaning it's releasing gas and dust. The green specifically comes from diatomic carbon C2 molecules in the coma, the fuzzy atmosphere around the comet's nucleus.
Diatomic carbon.
Yeah, and when the sun's ultraviolet light hits those C2 molecules, they fluoresce. They essentially light up, glow this characteristic green color. It's a sign the comet is actively shedding material as it gets heated by the sun.
Gotcha. And these aren't just quick visits, are they? These comets have been traveling for a long, long time.
Oh, absolutely. These are true long-period visitors. Ancient travelers from the outer solar system.
How long are we talking? Like, when will they be back?
Well, for Lemmon, its orbital period is roughly 40,350 years. So don't hold your breath. Maybe around the year 3179.
Wow. Okay. And SWAN?
SWAN's orbit is a bit trickier to nail down precisely. Estimates range quite a bit, maybe somewhere between 650 years on the shorter end, but possibly as long as 20,000 years.
20,000.
Yeah. So the bottom line is, you're seeing them now, or, well, never again in our lifetimes. And today is really the peak opportunity because they are both basically at perigee.
Perigee, that's closest approach to Earth, right?
Exactly. Closest point to us.
So what are those key distances for today, October 21st? How close are they getting?
Lemmon hits its perigee today at about 28.6 million miles. That's roughly 46 million kilometers away.
Still pretty far, thankfully.
Oh, yeah. Absolutely zero hazard to Earth, none whatsoever. SWAN actually got even a tiny bit closer, reaching its minimum distance basically yesterday and today.
Closer than Lemmon.
Yep, around 24 to 25 million miles, or about 39 to 40 million kilometers. That closeness is why they're potentially so bright and great viewing targets right now.
Okay, let's switch to the practical stuff. Viewing strategy. If someone just wants to step outside tonight, maybe without equipment first, which one should they aim for? Lemmon.
Definitely Lemmon. That's going to be the main event if you're hoping for a naked eye sighting, or at least an easier binocular spot.
Why is that?
It's simply the brighter of the two right now. Recent estimates put it somewhere between magnitude 4.2 and 4.9.
Which is?
Getting into naked eye range, potentially, especially under really dark, clear skies. It might even push towards magnitude +3 or +4. It'll look like that fuzzy greenish patch we talked about.
And where and when should we look for Lemmon?
Okay, viewing time is evening, definitely. You want to look fairly low on the horizon towards the northwest after sunset.
How long after sunset?
The best view tonight will probably be about, say, 90 minutes after the sun goes down. That's when it should be highest and clearest above the horizon haze.
Right, northwest, 90 minutes after sunset. Now, how do we pinpoint it? You mentioned a trick, something about a banana.
Yeah, the banana-shaped curve trick. It's a classic sky navigation technique using a very familiar star pattern.
The Big Dipper.
Exactly. Find the Big Dipper Ursa Major. It should be hanging in the northwestern sky this time of year after sunset. Locate the handle, the curved part.
Got it.
Now, imagine tracing that curve downwards towards the horizon. If you follow that arc about halfway down, your eyes will land pretty close to Comet Lemmon.
Near which star?
It's near the star Corcoroli, which is in the constellation Canes Venatici, the hunting dogs.
Okay, trace the Dipper's handle curve halfway down. Is there another guide?
Yeah, the other classic saying, arc to Arcturus. Arcturus is that really bright kind of orangey star over in Booties.
Right, I know Arcturus.
So if you follow the arc of the Dipper's handle towards Arcturus, the comet tonight, October 21st, will be roughly 2/3 of the way along that imaginary line towards Arcturus.
2/3 of the way from the handle towards Arcturus. And how high up?
Around 16 to 20 degrees above the western horizon. So maybe like 1.5 to 2 fists held at arm's length. Look around 8 p.m., 9 p.m. local time.
Perfect. Okay, so we find Lemmon using the Big Dipper. Now, after that success, maybe we're feeling adventurous and want to find SWAN.
The next level challenge.
Right. Now, here's something interesting. You said SWAN is actually a bit closer to Earth right now?
It is, yeah.
So why is it significantly fainter than Lemmon? That seems weird.
That's a great question, and it ties right back into that whole inbound-outbound difference we talked about, remember?
Lemmon's inbound, SWAN's outbound.
Exactly. SWAN already flew past the sun. It experienced its peak heating, its maximum vaporization back in September. Now it's moving away from the sun.
So it's cooling down.
It's cooling down, becoming less active, shedding less gas and dust, even though it happens to be physically closer to us right now on its trajectory.
Okay, that makes sense. Less activity means less brightness.
Precisely. Its brightness is fading. It's probably sitting around magnitude 5.9 to maybe 6.3 now.
Which means
you'll almost certainly need binoculars. Or a small telescope. Naked eye is probably out of the question for most people with SWAN. But binoculars should definitely pick up its greenish glow and maybe a hint of that fainter gas tail.
Okay, so grab the binoculars. Where are we pointing them to find SWAN tonight?
For SWAN, you want to shift your gaze to the southwestern sky. Also after sunset, look about 30 degrees above the horizon, so roughly 3 fists high at arm's length.
Southwest, 30 degrees up. Any guide stars?
Yes. The key here is the summer triangle, still visible in the autumn evening sky.
Vega, Deneb, Altair.
Those are the ones. Find that big triangle. SWAN is located roughly halfway between the lowest star of the triangle, Altair, and the horizon line directly below it.
Halfway between Altair and the horizon. Yep. Got it. Southwest.
Yep. Binoculars ready.
Now, connecting this back to the bigger picture, you mentioned these comets have really different journeys, different paths. Lemmon's highly inclined, retrograde. SWAN's low inclination, prograde. What does that difference actually tell researchers about where they came from?
It tells us they likely originated from different regions, different dynamic populations way out in the solar system.
I'm like,
Lemmon's path, highly tilted,
yeah.
going backwards compared to the planets. That's a classic signature of something coming from the Oort cloud.
The Oort cloud. That vast sphere of icy bodies way, way out past Neptune, right?
Exactly. Billions of them, maybe trillions. Very distant, loosely bound to the sun. SWAN, though, with its orbit closer to the plane of the planets and moving with the planets, that suggests a different origin.
Not the Oort cloud.
Probably not directly. Maybe the scattered disk, which is a region closer in than the Oort cloud beyond Neptune. Or maybe it had a more complex journey involving gravitational nudges from planets. Seeing both types show up together like this is scientifically really exciting. It gives us snapshots of different deep space reservoirs.
That is fascinating. Okay, given how incredibly dark the sky is tonight thanks to that new moon, let's give some practical gear advice. How can people maximize their view this week?
Right, gear. First off, if you have binoculars, use them. Even for Lemmon, they'll make a huge difference.
Why binoculars specifically?
Because comets aren't like stars or planets, which are tiny points of light. Comets are fuzzy, diffuse, kind of spread out objects. You want a wide field of view to capture that whole fuzzball appearance.
And binoculars provide that.
Exactly. Standard binoculars, something like 8x42s or 10x50s, are perfect. They gather enough light to really show the coma, that green head, and maybe even the start of the tail, especially on Lemmon.
Okay, binoculars are king. What about telescopes, if someone has one?
If you've got a telescope, the key advice is resist the urge to use super high magnification.
Really? Why not?
Because high power zooms in so much that it basically makes the faint, fuzzy comet spread out and disappear against the black background. You lose contrast.
Ah, so low power is better.
Yes. Use your lowest power eyepiece, something giving you maybe 25x to 50x magnification. That will keep the view wide enough to frame the whole comet coma and any visible tail and maintain better contrast.
Good tip. Any apps or websites you'd recommend for tracking them, especially if they move slightly night to night?
Oh, absolutely. Technology is your friend here. Apps like Sky Guide, Sky Tonight, Sky Safari, those are fantastic. Also websites like theskylive.com or Stellarium, which is available as software and a web app. Those show you exactly where the comets are in real time for your location. Super helpful, especially for tracking the fainter SWAN.
Great resources. And just to really drive home why this week is so special, it's more than just the two comets, isn't it?
It absolutely is. We have that peak of the Orionid meteor shower happening right now, tonight, and into tomorrow morning.
Caused by Halley's comet debris.
That's the one. So you might see these fast, bright meteors streaking across the sky while you're hunting for the comets. Plus, you've got the maximum darkness from the new moon. It's this incredible convergence.
Two comets, peak meteor shower, no moon.
It makes October 2025 a really standout month for sky watchers. We haven't really had anything quite like this alignment, especially with two potentially naked-eye comets since Comet Neowise back in 2020. Remember how amazing that was?
Oh, absolutely. Neowise was spectacular.
This is maybe not quite that bright, but the combination of two decent comets plus the shower and the dark sky, it's special.
So wrapping this up, what does this all mean? It means basically right now, this week, you have probably the best possible chance to see two comets that won't be back for many, many centuries, maybe millennia in SWAN's case.
Yeah, it's genuinely a generational viewing opportunity.
And the best part, you don't need to travel to some remote observatory. You just need maybe some binoculars, a reasonably dark spot away from city lights, and to look up.
Exactly. And that actually leads perfectly into this final thought. Something kind of mind-bending about cosmic physics that this whole event highlights.
Oh, go on.
Well, we established Lemmon's orbit is about 1,350 years, right?
Right, give or take. Next return around 379 AD.
Okay, but here's the thing. That 1,350-year journey used to be longer. It was actually shortened by nearly 200 years because of a previous close flyby Lemmon had with Jupiter.
Wait, seriously. Jupiter's gravity, way out there, shaved 2 centuries off this comet's massive orbit, just by passing relatively close.
It did. That's the power of gravitational interactions, even seemingly subtle ones over vast distances. These long-period comets, they spend most of their lives creeping along incredibly slowly in the outer solar system. But when they swing inwards, into the realm of the giant planets, even a near miss with something as massive as Jupiter can give them a significant gravitational nudge. It's called gravitational scattering.
And that nudge can change their speed, their momentum.
Exactly. Enough to alter their orbital period quite dramatically. In Lemmon's case, shaving almost 2 centuries off its next return date.
Wow.
So the provocative thought for you as you're out there tonight, looking at these faint, fuzzy visitors that have traveled for millennia, just contemplate that. How these seemingly tiny gravitational tugs between planets and distant icy bodies can fundamentally alter their entire future path. Their predicted return dates thousands of years from now. It shows how interconnected and dynamic the solar system is, even on these immense timescales. How seemingly minor interactions sculpt the eternal timelines of these cosmic travelers.
That is a pretty profound thought to end on. The subtle dance of gravity shaping millennia. Incredible.